Hello everyone, this is lecture 80 of Principles of Electric Circuits. Let's discuss decoupling equivalence of the mutual inductance. After introducing the concept of dot convention in lecture 78, in fact, from time domain and phasor domain, we can write the expression of the mutually induced voltage according to the dot convention, but in practical application, two mutually inductive coils are often connected together. In this lecture, we took a look at how to simplify the circuit analysis for different connection ways. We discussed three types of direct connection, that is parallel, serial, and single-point connections. The mutual inductance of a four-terminal component serial connection refers that we connect the two coils head to end, that is, eventually A and B are two terminals for external. Similarly, if we connect two mutual inductance coils in parallel, they are also two terminals for external. The so-called single-point connection refers to that the one terminal is connected between two coils and thus forms three terminals network for external. We will discuss the equivalent circuits of the three connections. The first is the serial connection. It is not difficult to imagine that there are two cases of the serial connection. We call the first case the ordinal serial connection, the second one the reversal serial connection. We will derive them respectively. For the first case, we use KVL. Coil 1 has two voltages. That is, the self-induced voltage and the mutually induced voltage respectively. For the self-induced voltage, due to the associated reference direction of U1 and I, is positive. For the mutual voltage, because the voltage flows into coil 2 from the dot, so the induced voltage of coil 1 is positive above and negative below. The direction of the path is like this, so the mutually induced voltage is also positive. Using a similar analysis method for coil 2, we can get simplify the equation. We can get this equation is very similar to. We know that if two circuits are equivalent, the relationship of two-port voltage and current must have the same form and parameters. By comparing these two equations, we know that LEQ equals L1 plus L2 plus 2M from the ordinal serial connection. That is to say, we can replace the two mutual inductance coils in ordinal serial connection by an inductance LEQ. We can also use KVL for the reversal serial connection. For coil 1, U1 and I are associated reference directions, therefore the self-induction is positive. The current flows into the coil 2 from its non-dot, so a mutual induced voltage with negative above and positive below is generated on coil 1. Because the direction of the path is downward, so the mutual voltage is negative. Similarly, the current flowing into the dot of coil 1, it produces a mutual voltage with negative above and positive below. So for coil 2, U2 and I are associated reference directions. So simplify the equation, we can get. So LEQ equals L1 plus L2 minus 2M for reversal serial connection. These two conclusions are relatively easy to remember.